most appeal to me working at the internship at NASA was to be around world-class researchers that are focused on an area such as air traffic control that is very relevant and interesting, and it can really touch a lot of people's lives. SARTA is NASA's spot and runway departure advisor, which they use to schedule aircraft at the entrance of the taxiway. In order to use this schedule, they actually have to have aircraft transition from the ramp area to the entrance of the taxiway at fixed times. What my internship focuses on is computing these pushback windows for departure aircraft. The research questions that we're looking to answer are primarily how to anticipate and handle uncertainty within the ramp area. For the most part, when the aircraft are on the taxiway, it's pretty well understood how they move around. But in the ramp area, for example, they get pushed back by a tug, and after the tug pushes them back, they go through an uncertain stop period where the pilot has to spool up the engines and go through a checklist. This could last from anywhere from 50 to 400 seconds. And then they finally taxi to the entrance of the taxiway. So when you're trying to schedule aircraft and you have this type of uncertainty in just one of the aspects in the ramp, that can create a lot of difficulties in trying to schedule things. And so what we do is we compute these pushback windows to help controllers meet these schedules that NASA has computed. The research started out where Professor Milutinovic had an idea to use robots to actually simulate the surface of the airport, because previously we had no data related to how the aircraft move around. So we were able to get some data, which then we used as input to a stochastic model of aircraft trajectories, which we used to sample a large number of feasible ramp area aircraft trajectories. These feasible trajectories are then used to compute these pushback windows using a mixed integer linear program. And so what we're able to do is we're able to take these sets of feasible ramp area aircraft trajectories, compute some probabilistic model of conflict, and then using a mixed integer linear program, actually compute pushback windows that ensure that there's zero probability of conflict. The most rewarding thing about working at NASA has been really getting to collaborate with the researchers at the NASA Ames Research Center and getting to be around people that are at the top of their field and have domain expertise in many different areas. If another student were to ask me about applying for an internship at NASA, I would tell them that I think that they should definitely do it. It's opened up a lot of opportunity for me in my own personal research and development as an academic.